Hello, this is Bob Schroyer from Nancy's Knickknacks. Today I'm going to refurb this ball winder. I just got this ball winder back from a customer, and we're going to see what's wrong with it. They said it was not performing as well as it should. First thing to do is we'll take the handle off. From the date code, it looks like it's from August of 2010, so that's about 3 years ago that this shipped. You'll notice that feet are coming off, not a big deal. We'll put 2 new feet on there when we're done. So when I first did the spin test with the handle, I'll put this back on, it's pretty stiff. Now what that tells me right off the bat, assuming that this is not too tight, this is pretty tight up here, so there is an issue there that I have to address by loosening that up. Could be the age of the O-ring, could be too tight against the shaft, but what it basically tells me is that the difficulty in turning this handle, although you can't really observe that, but I can feel it. There's a lot of drag in there, and I guarantee you when we open this thing up, it's going to be full of fiber in the gears. So we'll first take off the collar of the spindle shaft. Now what you're looking for on this clamp ring is that it had at least one seam on one side, and this appeared to have that. So at this point, this does not need to be replaced. Sometimes this ring, if it's fully closed up like that, you cannot tighten the assembly any further, and it has to be replaced. That problem was introduced by a number of causes, one of which this tube here, the torque tube, came in under spec and it was not discovered early enough. So that only happens in a certain percentage of cases, but if you do have that problem, you'll see that once this is in place, both of these will be closed up. There will be no adjustment, in which case this clamp ring assembly needs to be replaced. So what we'll do now is we'll take the ball winder apart. We'll start with this collar here. Take that off, washers, torque tube, a little bit of dirt in there. That's not the problem, however. The problem that we'll see, if it has the problem, will be inside the big gear that you can see spinning around in there. Just taking this apart, I noticed that this is in there so tight, they must have hit this with a hammer, driving that peg into the base. So rather than try to force it out and run the risk of breaking it off, I'll just continue to take the bottom of the unit off. And I noticed on this base, one of the screws is missing. So at some point they had it apart and they didn't put the screw back in there. Not catastrophic, but not a good idea. You can see how that base comes off. This shaft actually goes into that hole right there. Twist that back and forth and it'll come off the shaft. You don't try to pull it straight off. It's much easier to do it that way. Now as we look inside there, it doesn't look too bad. But you really can't tell until you take the next set of screws out. So the first set, there's 4 screws, or hex head screws. They hold the base to the body of the ball winder. The next set of screws are Phillips head screws. take those out. Now I'm going to abandon my drill for this one because my drill bit doesn't seem to be the proper fit. So I'll just use a regular Phillips head or Phillips screwdriver here to remove the 3 screws by hand. Use a number 2 Phillips for this. Then you just pull these 2 halves apart. And you have to jiggle them a little bit. Make them right apart. So if you notice what I just did, I took the 3 screws out and I pulled these 2 halves apart. And what that shows me are the gears. The main gear here. Okay, I'm going to pour some rubbing alcohol. Get this at the drugstore. 91% isopropyl alcohol, standard rubbing alcohol. And why do we use that? Because it's a good solvent. It seems to be less toxic, let's say, because it evaporates fairly readily. But it also removes all the greases and grime. It softens the fiber that will be on the gears. And what we're going to do is we're going to soak this big gear. This big gear just slides right off of there. And you notice there's a washer underneath. You'll also notice this white grease. Back in when this unit was made, we were putting on a white lithium grease. And oftentimes it would accumulate and actually attract fiber. Now this, I can tell that this customer actually cleaned this out at one point. I very much doubt that this is the original condition of that gear. So as you can see, I'm soaking that in rubbing alcohol. I'm also going to want to get it over the upper part of that cluster gear as well to get that white gunge off of there. What actually happens with that grease, we didn't know it at the time, but when we were using it, it would go on and be greasy enough, but over time it would harden up and actually get tacky. And that would actually restrict the motion of the gear turning, which was the last thing we wanted to have happen. So a few years ago we stopped using any grease at all on the nylon gears. They didn't really need any lubrication. We do put a thin film of oil, 3-in-1 oil, on the metal shafts because they tend to squeak if you don't do that. See if we can get this washer off of here. So take that washer off, soak that. Trying to get, again, that white grease off of there. And I'm soaking it. Now these gears are not very bad. Sometimes I take these gears apart, they are loaded. They are packed in these gear crevices with a lot of fiber, and that's what makes the unit slow down and be hard to turn. What we'll do is we'll clean this stuff out as best we can. Doesn't really do anything in there, but it's not necessary. It'll attract fiber, and we just basically want to get rid of it. This shaft here, it's an intermediate shaft. It holds that cluster gear. So that gear rotates around there freely. So what we're going to want to do is put some oil in there. After I take some of the rubbing alcohol and remove any of the old grease from that assembly. And of course you want to get the fiber off because there's any fiber. Usually the fiber will go to the bottom, just like it did there. So once it's free of the fiber, what I usually do is take a Q-tip, make a sharp point on the Q-tip, and then you can push it in and out. So you can see there's fiber coming out of there. It wasn't anywhere near as bad as I thought it was going to be. But you know, the combination of the grease, the fiber buildup, maybe the unit's a little bit out of adjustment, so on and so forth. It doesn't take much to slow the unit down. And even though you're turning it by hand, and you have tremendous leverage with the handle, you'll feel the increased drag caused by all these issues. Now you notice this thing is 3 years old. There's no wear on those gears. The gears are almost as if they were brand new, which means that nylon material is really tough. It's not susceptible to any significant wear regardless of the amount of usage. What does that mean? That means you could literally run this thing for your entire lifetime. Provided you clean it out, oil the shafts, replace the O-ring on the flange, and we'll do that in a moment. Another great tool to use is an old toothbrush. You just go back and forth and pull that fiber out. It's actually probably much better than what I was using there with the Q-tip. It's just I've been using the Q-tip method for a long time. But the old toothbrush method probably works the best and easiest. Again, you're going to get that upper gear as well. It's called the bevel gear. The big gear is called the spur gear. You see, by bathing it in the alcohol too, you're removing any greasy material. Then you can dry it off. That gear's pretty clean now. So what I would next do is put some 3-in-1 oil on that shaft. You're just putting a thin coat of oil on there. Now, reposition that gear. Oh, I forgot to do one thing, didn't I? I forgot to put in place this washer, which is critical. It's a spacer. Anytime you see a white washer in the bow winder, it's used as a spacer. You got to remember we're dealing with wood here, and it's cut by a man, you know, and a machine. So it's very difficult to get precision cuts that are always the same thickness. So you have to make up the variances with spacers. Once again, you want to wipe off any grease on there. Again, put a little bit of oil on there. Take our gear and rotate it. Now that gear assembly is clean, and we're essentially done with that part. Now, the main bevel gear is inside the housing. We cannot take that out. It's trapped in there and secured with a pin that actually goes through the gear into that metal shaft. Notice up here as well, the shaft goes up there, and we're going to lubricate that spot as well. So the best thing we can do in this case is you can take the toothbrush or your Q-tip, or you can just take a rag. Oftentimes I'll rotate the shaft by putting my finger with the towel or paper towel up there, and as it goes around, I'm picking up all the debris that was in there. Go back and inspect it. If you find that it was not doing as thorough a job as you'd like, then you again take the toothbrush, trying to get the grease out of there, the fiber. You see any other grease in the area? Want to get that off? You see how freely that moves? There's a bearing there, and there's a bearing in there. So that shaft is supported by special German bearings that we have in there. So what I normally do is put a drop of oil on that bearing down there, and on that shaft there, which also makes contact with the bearing. One other spot would be right in there, not that shaft there. I misdirected that oil, but that's okay, you just wipe it off. You want that to turn really freely. Go back and forth, make sure there's no obstructions, make sure there's no dirt in there at all. Again, you do the best you can with any of this white guns you see there. On newer machines you won't see that because we stopped using that lithium grease. Oh, I'd say about 3 years ago. So maybe right after this was made. If this were made in 2010, it could have been right after that time period. Okay, so that's all ready to go. So what we do at this point is, now remember we had a washer, we put that washer back in place underneath that gear. There is no washer here that we need to worry about. There will be a washer that we're going to have to put at the base of this shaft. And while we have this shaft available, we should take the paper towel, take some rubbing alcohol, and make sure you get any gunge off of that thing. That's your torque tube shaft, very critical shaft. It's a pointy shaft that that the O-ring rides on. So make sure that there's no grease or anything on there. We will put some 3-in-1 oil on that surface later, but we want to start with a fresh, clean metal surface. So what we're going to do is poke this back in here. Whoops, I got it upside down. Oh, that's right. Got to make sure you have the right halves together. So they go together as two pins that we call locator pins that help us make sure we got that locked in place. So when you put it together, remember this shaft sticks out the bottom. This is where your arm's going to go back and forth. You can see the bevel gear here. So at this point, make sure everything turns freely. If you look down that hole, you can see that gear turning in there. So at this point we would take the Phillips screws and screw this half together. I'm going to tighten it securely. Okay, so that's the body of the ball winder. Good test this one. As you spin that shaft, it should spin really freely. When we put the torque tube in there, which we took off early on, I should have really put this in the, I like to soak this in the rubbing alcohol. See, I put it back in there. That has a gear on it as well. That's another spur gear. That connects with the big spur gear that we were just looking at, and the one that is usually the one that gets the So this thing here, we take our toothbrush again. Sort of rinse it in the rubbing alcohol. Get another paper towel here. Okay, it looks pretty clean. The washer that was underneath it, I see this is why I normally put the paper down to prevent this greasy stuff from getting all over my table. So remember that when you take it apart, you know, you want to put some protective paper down or something. Paper towel would work. This washer goes underneath the torque tube. There's another one that I have over on the side there, which I'll show you in a moment. That goes on top. Okay, so this we're going to put down. Some fuzz go back in there. Sometimes you'll get fuzz that is stuck to the sides of the wood here. So if you see that, just make sure you get that out. Put that washer goes down the torque tube shaft. Now at this point I'm going to put a little bit of oil on that shaft, and then I'm going to run the torque tube up and down to make sure there's some oil on the bearing surfaces. Bearing surfaces are where the shaft makes contact with the torque tube. So you can see now when I turn, see how freely that turns? Sounds good, feels good. Everything's working the way it should. Now the washer that was on the top is kind of nasty and dirty. So we'll put it in the rubbing alcohol once again and clean that off. At this point though, I'm going to put the unit back on the base, and then we'll do the final assembly on the torque tube. You see how that coloration or discoloration occurs? That's patina. The wood, as it ages in the air and in its environment, will get darker. And you can see where the wood was protected by the ball winter housing. So, something you can do about that. That's the way wood is. So, but that's why that happens. So we'll take the housing out at this point. We're going to put this back together. Remember, this shaft goes in that hole. So what I usually do is position it on that shaft, and I try to look through these holes. You can also try to align your thing on the bottom. You'll know when like if we were like this, obviously that's not a good fit. But you'll be able to get in the ballpark. And then you'll find the screw holes. Now remember, we were short one screw here. This unit came back without a fourth screw. So I'll have to get one from stock, but I don't have it right at this moment. So again, we're missing a screw there, which I'll have to put in before we... Oh, what did I do wrong? What I did wrong was a common mistake. I forgot to put the tensioner post arm back on. So we're going to take those screws out. Make sure you don't do what I just did when you go to put it back together, because we have to have that post on there. If you do mess up, it's pretty easy to sort it out. Take the base off again. What you do with the arm, and normally you would have this post off. I don't recommend really doing it with the post in place because it just acts like a big lever. You're apt to grab it. Remember the problem we had with this too? See how far that was driven down? So now I'm able to grab it properly and get it out of there. But as a rule, you don't need to pound that in so far. You just press it in. It's just there to keep the arm from swiveling left and right. So you always want to make sure the slot is facing up to the sky or the ceiling. You put that hole, the shaft through that hole. Yours may be tighter than that, in which case, you just swivel it back and forth as you're gently pushing, and eventually it'll go on. So let's try this again. So we put the shaft in that hole, find the screw holes. Boy, I don't like this magnetic drill bit. Okay, so that's all back together. Notice this turns pretty freely. Yours may turn a lot tighter. It doesn't really matter at the end of the day because once you put the peg in place, this particular one, I noticed that this peg, part of the problem is it's kind of tight in this. Maybe too tight. What I'm going to do is I'm going to replace that peg. Okay, I got another peg and put that in, so that is a lot better. If you do run into a problem with the peg or if it's too thick on the shaft here, you can always take some sandpaper and just sand that down. The problem with dowels, when you buy dowels, they never are to spec as a rule. They're either slightly bigger or slightly smaller. Very difficult to engineer stuff using dowels because the holes that you're putting the dowels into oftentimes are, you drill those, so those holes are right to specification. But the dowels themselves are not, so it's always a tricky situation. So the good news here is if it's too thick, you can sand it down yourself and then get it through this arm. If the arm is too thick for the dowel, you can then re-drill this hole with a slightly bigger drill bit through this arm. You'd have to take the arm off first to drill so you wouldn't hit the base, but it's quite possible to do that. Okay, so we're going to put some, I think I already put a little bit of oil on this shaft, but I'm going to do it again. And we're going to run that torque tube up down. We already have a washer down there. And I'm just running that up and down. Make sure no squeaks. Everything's got a light film of oil there on these surfaces. We're then going to put this washer. It's a spacer, but it's also a bearing surface for these parts. Now the collar will go on next. The collar locks that assembly in place and prevents it from coming off. You want to remember when you're putting these collars on to not make them too tight. In other words, there's no need to push it down. If you push it down too hard, then it restricts the motion of the torque tube. So the best thing to do is push it down all the way and then slightly bring it up, maybe about a 32nd of an inch. And then tighten it. Make sure it turns freely. It has a little gap in there, there should be no problem. This one here, I'm going to make it just a little bit more of a gap. Even do what I'm doing there, right? raising it up and down, no problem. That way there's no possibility for that thing to get pinched in there. Once again, the only purpose for this collar is to keep the torque tube from coming off. Alright, so now what we want to do is make sure we leave no oil on this surface. Now remember we put the 3-in-1 oil on it, but the last thing I want is any oil on this surface, because that's where my rubber O-ring is going to touch. So make sure you take the rubbing alcohol, clean that off. Alright, so now that the whole guts of the ball wing now has been inspected, it's been cleaned and lubricated, we're good to go there. Next thing we should check is a spindle. You know, spindle should have washers up there. They vary, the number of the washers will vary, and it adjusts the height of the unit. We're going to put a new O-ring on. This old O-ring is probably 3 years old. Still looks good, there's no cracking. If you had cracks in there, let's say you're in a desert environment or somewhere and it's very dry, the rubber can actually crack when it dries out. So you put a new O-ring on there. You should do that every few years. But you know, if you don't have access to one, you didn't order it from us or what have you, then keep using the old one. But again, look for any visible cracking. Anything that's deformed on the O-ring will cause a problem when you're winding the ball. This is a bearing surface in here as well, but it's press fit and you don't need to worry about lubricating or anything. This turns very slowly in reality. You know, sort of like that. It's not really going super fast, so it's not being subjected to high RPMs in this area. Okay, so the next part is we're going to put that down. We'll probably have to tighten these screws up a little bit because it seems like it was loosened quite a bit, maybe when I was taking it off. Basically, when you fit this back on, you don't want to wiggle them too much, side to side. Now on this side, you can't really see it probably, but this seam is pretty much closed up. Over here I still have a seam. You just have to have one seam. You don't have to have seams on both sides, but you have to have one seam that's still visible, that you can actually still tighten up. So I can raise this up and down at this point, and when I get it to where it's making contact, I can turn it. That feels about right. But if it didn't feel right, I'd loosen that screw up again. Just loosen up, raise it up or lower it down. When I say lower it down, you might have to pull it down. You grab a hold of this assembly here and pull it down slightly. Here you can see I have a seam now on both sides, so it's tight. You don't need to over tighten this. Some people torque it down so much that contributes to the premature closure of that seam. But this is fine where it is. Okay, we'll do a spin test here. Normally I don't tighten it, so I'm in a strange position here given I have to have the camera right over my shoulder. So it's hard to maneuver in this space, but so what I'm checking now is how many times it spins around on its own energy after I let it go. And I'm also looking at this slot up here. Now I notice after a crank or two it's going to rotate in this direction. If I were to go counterclockwise, it would go in the other direction. It doesn't really matter which direction you're going. But what matters is that that slot is slowly but surely turning after a few cranks. You see it's now going this way. Now it's going that way. So what that's showing is that this is working. As this turns around, the O-ring pressing against that shaft is forcing the spindle now to turn. And it's these two actions, the rotation of the whole assembly and the additional rotation of the spindle, that actually creates the ball of yarn. If you make it so tight that it can't do that, then it won't work. You'll have a wonky ball. In fact, if you have anything that's super tight and preventing things from rotating freely, you will run into problems. So once again, we'll do the spin test. 1, 2, 3, 4, 5, 4 to 6 turns of the handle after you let it go like that is the right number. If you're down near 3 turns or less, you're way too tight. Meaning this O-ring is way too tight against that shaft, and you have to loosen these 2 screws, raise it up a little bit, because that would be the direction you would make it looser. If it were way too loose, you would pull down on this assembly as you loosen those 2 screws. You pull it down, forcing this O-ring to press more tightly against that shaft. So make it tighter, you pull down. To make it looser, you go up. You can pull down or push up while you're turning this once you loosen those 2 screws. And that's what I suggest you do. You loosen enough so you can go up and down. Here, I'll do it one more time for you. So you only loosen these a quarter turn roughly. See, that's enough. So now I can go up and down. So now if I just barely touch it and I can turn it too freely, that's probably too loose. I have to have traction here. So I can pull that down. I'm pulling down now. And if it's too tight, I push it up. Keep turning it, and that tells me, okay, that feels pretty good now. And then the test says on the 1, 2, 3, 4, 5. Look at the, again, the slot. Now it's facing down, so everything's working the way it should be. At this point, I would say this unit has been serviced, okay? It will make a ball. I don't need to wind a ball to know that this will work at this point. It's just not necessary. Sometimes I might do that if somebody had some particular problem and they're overly concerned that, you know, something's still going to go wrong. So, but in most cases, once you do this setup, and this is why we do brand new setups as well, we know that it will work once it does those 2 things. It rotates, this rotates freely up here, and the amount of tension is demonstrated by the number of turns it makes. So that's pretty much all there is to it. Now we'd have to put the post back on. You'll notice I didn't do that. I'm going to take the handle off at this point as well so I can get a little closer to the unit. You want to make sure you always torque your handle down. Put the bolt up through there. If it feels like it's not going smoothly when you put that bolt into the post, then take it out. You could be cross-threading it if you're not careful, so you don't want to do that. You also want to position it. You'll notice how I have the curlicue going here. Alright? I don't have it aiming straight at the spindle, and that puts a little bit of tension on it. You'll also notice I have the post all the way in the inner position here. So you don't want to push it out to the outer position unless you're making a really big ball. So that's the right way to set that up. Either this way or that way, depending on where your swift is. If my swift were over here on the left, I want to bring the yarn in from this direction, assuming I'm going clockwise, and I want to feed the rotation, meaning the yarn comes through here, goes to the outside edge over here of the ball as it's forming. If the swift were on the right, I would reverse that post. But in both cases, I would put about a 30-degree angle or so on this, on the wire guide. So hopefully that answers some questions as to how to clean and lubricate the unit. Every situation is a little bit different, of course. You know, you get inside there and it could be filthy, rotten, dirty. I've seen them where they look like they've been running for 20 years. And if you ever sense that there's a lot of drag when you're turning the handle, first check the O-ring to make sure it's not too tight, and then secondly, check inside. Something is obstructing something somewhere in the assembly, and it's got to be one of those 2 places. The other possibility could be that the Swift is a real drag on the system, but I'm assuming you're going to take care of your own issues with your Swift, but that it can also be a factor. So if you have any questions, please feel free to contact us at 800-731-5648. Thanks.